Hi, and welcome to Adaptive Learning and Math Remediation in Chemistry. Thanks for joining us today. My name is John Britch, and I'm a marketing nerd here at Knewton. To preserve the sound quality, you've entered this conference muted. If you have any questions during the session, please type them in the question box, and we'll answer them during the Q&A segment. Let's actually try that now. If someone could enter in the question box if they see me, hear me, and see the slides. We just need one person. Ah, beautiful. Thank you, Mark. And so if you have any questions, type them in that question box as Mark did, and we'll answer them during the questions and answer segment. You can also use the chat function if you want to send me a message. So this presentation will be recorded, and I'll send you a link to the recording after the session. So during our 45-minute session, we'll cover why Alta can be especially useful in entry-level chemistry courses, what exactly the Alta courseware is, since it differs from other homework and courseware, and then we'll save the best for last, which is best practices for using Alta in a course. So with us today to help answer these questions are Dr. Donna Jean of Park University and Dr. Andrea Pellerito. Andrea is Senior Content Developer at Knewton, and she'll speak more to her background, which includes teaching college chemistry and developing course materials for that and other course areas a little later in the session. Donna is Associate Professor of Chemistry at Park University, where she currently serves as Director of Liberal Education and previously is the Chair of the Department of Natural and Physical Sciences. So let's start off with Donna. Could you tell us more about yourself and your background and your students?
Sure. Hi, everyone. As John said, I am an associate professor of chemistry. I've been teaching at the undergraduate level for a little over 20 years now at both public and private institutions, always smaller four-year institutions, but my class sizes have varied anywhere from the very small to the very large classes. I've been at Park now for about 11 years. I am tenured, and I really believe strongly in Park's mission that we transform lives through accessible, student-centered, quality higher education. We are an open enrollment institution, meaning that pretty much anyone that has a high school diploma or the equivalent is admitted regardless of their preparation for college level learning. As such, I am particularly interested in preparing or helping those students that are less prepared for college, who may have more challenges in adapting to a college science course, but I still want to hold those high standards in my course for the students. I myself was one of those underprepared students, and through the help of some really great teachers, I was brought along to increase my study skills and really excel in science. So next slide. Tell you a little bit more about Park University and our student body. Our average student age is a little higher than most typical four-year institutions. We have a very strong military presence, and so our students tend to be a little more on the commuter side and a little more older than the typical 18 to 22-year-old. We have an average of about a 24-year-old is our average student. Some of the adult learners are particularly enrolling in chemistry classes because we have a very large new four-year pre-nursing program, as well as a strong fitness and wellness program, and that is a degree that is very attractive to adult learners, and so they're taking that introductory chemistry GOB course quite a bit. We have a very diverse population as far as nationality. We have students representing over 100 different countries of origin. And again, their preparation for science and math is very diverse. To get a general idea of where students are, I've done a pretest, the ACS standardized GOB course as a pretest in my course to see kind of where the students are starting from. And I've done that for the past 3 or 4 semesters now, and you can see the data shown here. Most of my students do come in with a very low percentile preparation on that score or on that test. So most of my students are weaker in math and sciences. I do, however, if you look at the far side, have some students that are excelling even at the entry of the course. So I'm particularly interested in leveling the playing field for those weaker students and trying not to lose those students that already have a firm grasp of math and science. So I've utilized Knewton Alta in both my general chemistry course and in this introductory GOB course. The GOB course is the standard 5 credit hours lecture and lab semester course, a survey of general organic and biological chemistry. It is required for pre-nursing students and our fitness and wellness majors. The general chemistry is that general chemistry for science majors, and the traditional 3-hour lec, 3-hour lab. So I chose Alta because, well, for several reasons. Again, the main reason being I'm trying to find a tool that will allow those weaker students to get the help they need to stay up with the course material while not losing those stronger students. I chose Alta because the quality of the text and the quality of the content in general is on par with as the state-of-the-art texts that are out there, but it's at a fraction of the cost, and the design of the system is such that I can actually get students to interact with it rather than a book that they buy and never open. It supports the students with just-in-time help right when they need it, where they need it, and filling in knowledge gaps, particularly in the mathematics. That allows me to spend a lot more time dealing with chemistry concepts rather than trying to teach how to solve an algebraic equation, for example. Also, I really love the analytics that are provided from the program that inform me of how the class is tracking, how individual students are tracking, and it allows me to adjust my teaching to address those concerns in the classroom.
Super, thank you, Donna. So Donna will be speaking a little later in the session about exactly how she uses Alta with her students and, you know, showing examples of some of those analytics she's mentioning right here. But before we go any further, I think it's important and worthwhile at this time to actually talk a little about what exactly is Alta, because as I said a little earlier, it's different from other courseware. So Dr. Andrea Pellerito is going to help us out with that. So Andrea, if you could tell us more about yourself and Knewton as a company and the Alta courseware, that would be great.
Yeah, absolutely. Thanks, John, and thanks to everyone for joining us today. As John mentioned before, I came into this technology company environment from academia. I taught at a university, at Indiana University, for about 8 years, mostly organic chemistry, but a little bit all over the board as far as chemistry courses go. After I left there, I did work in the publishing industry in mostly chemistry and math and other physical sciences for about 6 years. And I worked both on the print and digital side there, you know, the traditional 3-year textbook revision process and digital development from that perspective as well. And again, that was in a variety of different disciplines. Earlier this year, going on just about 6 months ago now, I transitioned to Knewton so that I could focus just on the digital side of things without worrying about those 3-year revisions and the time it takes in order to make change in those big companies. So I came over here, like I said, nearly half a year ago so that I could really dig into the chemistry content itself, focus mostly on that single discipline, and also affect change very quickly. One of the really nice things about Knewton is how fast we can move and how fast we can change. Because I've had this academic background and this publishing industry background, I've really been lucky in that I've been able to dedicate a lot of years now to developing an understanding of how students learn, how students interact with online platforms, what their priorities are, and how those might be different from yours as an instructor, and finding a balance so that we can meet all of the needs of both instructors and students. So that's what we're working on here at Knewton. Let's talk a little bit about Knewton itself. As you hopefully know, what we've created is an adaptive system that surfaces content right when a student is ready to learn it, right when they need it, within the parameters of your own syllabus, your own needs as far as classroom management. But we also surface text at the same time. We know that students don't always read ahead of time. We don't see them most of the time effectively reading the textbook and then applying that later on. It's more of a real-time application of that. So as part of the Knewton platform, we're able to do that just-in-time introduction of text or video instruction. And basically, since all of that instruction and content and adaptive learning is surfaced in one place, we see that as an empowering you, the instructor, to teach the class however you want to. You can go at your speed, you can choose which learning objectives you're interested. We want you to see this as something that augments your classroom and also empowers you to skip topics that your students really do understand as a whole, or spend more time on problem solving or more time discussing topics that they're struggling with. And we're able to surface real-time data to you so that you know where to make those calls. You know where students need more help, or you know where you can change the conversation to something more meaningful to them. Next slide, John. So a little bit about Knewton itself. We consider ourselves to be a tech startup, even though the company will celebrate its 10th birthday next year. And the reason for that is that about 18 months ago, we wholly redesigned our mission. Before 2017, we largely partnered with a number of different publishers and supported their content with an adaptive online platform. So you may remember us from some of those now dated systems that we used to partner with. Mastering Chemistry, for example, used to partner with Knewton in order to have an adaptive system. What we found as we were doing that, and as we were collecting a lot of data from student usage, is that when we even had really great partnerships with some of those companies, there were platform limitations that meant that students weren't able to experience the adaptivity of Knewton to the best of Knewton's ability. It just was a limitation of those partnerships and of the platforms. So about 18 months ago, we broke most of those, or we ended most of those relationships, redefined ourselves as a whole content delivery company, so that we could have an all-in-one platform without relying on content from other sources. Invested $100 million, more than that, since the inception of Knewton in 2009. That number might be out of context, but I think it speaks to the care that we've given to researching how students learn, how to improve the system based on real student data, and so forth. So all that data that we collected from those partnerships, data from more than 15 million students, went into building a platform from the ground up. And that platform is what you're going to see today. That platform is Alta. We did need to curate some new content, though. So on the next slide, we'll see a little bit of where that content came from. So we partner with OpenStax, and that's a major way that we're able to keep costs to students down. A lot of our instructional content comes from OpenStax. In fact, and we'll do a little bit of a demo in a few minutes, you'll see instructional pages that look just like those OpenStax text pages with some revisions to make it broad use for all institutions. We also partner with a lot of different universities and professors, instructors from all over the country to write and edit content for us, both in the form of OpenStax and new content. For example, each learning objective, in addition to the OpenStax content, also has usually an average of 2 unique videos associated with it, and we partnered with instructors around the country to develop those. And then Knewton's content creation team, just about everyone on my team across all of math and chemistry has instructional backgrounds. We've taught in the classroom, we have instructional designers and so forth. So we're able to curate that content as well. And then we developed this team, this partnership of professors, our team, and a few others have developed all of the assessment content from the ground up since we redefined ourselves 18 months ago. Next slide. So when we talk about adaptivity, that's kind of a catchphrase for the last few years in higher ed online systems, right? So before we really dig into the product, I want to talk about what makes our definition of adaptivity different than it was when we partnered with other companies and different than other companies define it for themselves. When we talk about adaptivity at Knewton, it's really an on-the-fly adaptivity where every decision that a student makes influences what they're going to do and what they're going to see next. It's not prescribed like some of the other systems tend to be, where if you get the first question wrong, you're going to automatically see what we've predefined as a second question. You know, there's not a decision tree like you see on the slide in the same way that other companies do. We don't have a threshold that says if you get 3 in a row correct, you must know this topic. We rely on analytics to a much deeper scale there. Instead of having a pretest that dictates the adaptivity of the next several assignments, like I said, it's on the fly. I don't care what you knew last Tuesday when deciding what you are going to do today. I care what you knew 3 minutes ago. And we make all of our adaptive decisions based on that. And again, we're able to add some really rich remediation, both in terms of chemistry and in math, and all of that gets tied up in our adaptive system as well. We're able to figure out exactly where the student is struggling, if it's on the chemistry topic that you're teaching, if it's on a prerequisite chemistry topic, or if it's on a math topic. We're able to adaptively figure that out as well and remediate the student as necessary. And the reason for that, if we take a look at this next slide, is that as we built Alta last year, we were able to have very close linkages between all of our different subject areas. Right now, Alta plays in chemistry, math, and statistics and economics, math at the center of all of those other 3 disciplines, so that we're able to really use math as a core. Whether we're talking about chemistry or economics, if the student is struggling, oftentimes it's on those college algebra skills or sometimes some calculus skills or even pre-algebra skills, depending on what it is. We want to make sure that we're helping that student with exactly what their deficiency is so that then they can be effective in learning the topic that you're teaching in class. So I've put together just a brief little video giving an overview of how this remediation works. This isn't a full student experience, it's not a full assignment, but just to give you an idea of what happens from the student perspective as they're going through a chemistry assignment. So I put something together here for just one particular learning objective in our integrated rate laws. There's several learning objectives in that assignment. I just chose first order reactions for the sake of time. First screen, student's going to get some information about when it's due, average number, what the average student does. It's a little bit maybe small to see on the screen, but a listing of the learning objectives that are available to them. And they're given the option to read some background material on this, read that OpenStax page if they are the type of student who likes to read before they start answering questions. If not, they're able to jump right in and start with some questions. So let's hit play. And as we jump in, first thing student is going to see is a question. This one happens to be a more conceptual question. Student can submit an answer, and regardless of whether they get this question right or wrong, they're going to see an explanation. So even if they guess, they get some remediation there. Next question student sees, same topic, but this time it's a math question. Get it wrong on these free response math questions, students get 2 tries at it, so that if they entered something in wrong, they can have a second chance. Student got that previous question wrong. They see, again, a related but wholly different question. The student is clearly having some difficulty with this learning objective. We're coming at that, I know this is going a little bit fast and hard to read on the screen, but we came at that learning objective from a couple different perspectives. We're not just asking them to do exactly the same question over and over again. If you didn't understand, let's look at that concept a different way. Students struggled with a couple in a row. We gave them a video here, closed caption video, and then we ask a question directly related to that video. So probably a little bit lower level in most cases than the assignment as a whole, but just to make sure that they're understanding instruction that they just read. Student got the video question right, but then is still struggling with the assignment as a whole, which tells us that they probably need a little bit more help. And so what we did at this time is bump them back into a prerequisite. Instead of looking at first order reactions, now they're looking at how to identify the order of a reaction. And I'm trying to read the screen here, it's a little bit small, and rate constant units. So, maybe the topic at hand, they're just not ready to learn yet. So we bump them back to a chemistry prerequisite, make sure that they're answering those questions correctly. Again, it looks like the student is getting conceptual questions right, but is still struggling with computational questions. So we take a break from that. We can keep you in here all day long, but if you don't understand natural logs, you're not going to be able to do this content. So we take them out of the module, put them into what we call a math booster. We have them learn and practice natural logs, variety of questions here that they can solve. There's feedback, just like there was in the main module. There's more instruction, there's videos and OpenStax pages associated with this content as well. Idea being, again, get them up to speed on this math prerequisite. If the student, like we saw, is constantly getting math problems that are associated with natural logs incorrect, they can do that all day. But until they brush up on that prerequisite from a different math class, they're not going to get through the chemistry module in a meaningful way. So the student successfully completed that math booster, get back into the chemistry assignment, things are making more sense, and eventually they're going to work their way through and master this topic now that they have all of the right tools at their disposal in order to understand the chemistry. So student would spend longer usually in a module than this quick little overview, but I just wanted to give you a little bit of a sense as to how Knewton diagnoses where a student is struggling, but also supports them so that they're able to build up that skill set in order to successfully understand this Chapter 12 topic. So how do we figure that out from the back end? In that Chapter 12.6 module, it probably makes a lot of sense that the math that a student is going to struggle with is natural logs, right? We know that students aren't always proficient in that. In fact, many students are not proficient in that. So we can take an educated guess as to where they're going to struggle, but we go pretty far beyond that. At Knewton, we have a complete data science team whose job is to analyze how students are approaching their questions, how frequently they get things right or wrong, how they respond to instruction. Are they more successful after they look at instruction? Are they still struggling at the same rate after instruction? That's a good indication that we need to add supplemental instruction or do something different with what we have on there. That data science team partners very, very closely with our content team. They collect data based on their own studies or things that we specifically ask for, or things that instructors are curious about for their own courses. And then together, our two teams, along with some engineers and a few others from in-house, actually sit down and analyze those data together, take assignments as students to see where they're struggling and how we can improve that learning, those learning outcomes for students. So there's a lot that I'm not mentioning that data science team does, but the key is that our revisions are based on actual data. Of course, we take into account student reviews and instructor reviews. Those are all really important to us still, but we're able to use real-time data in order to affect change and in order to really come up with revision plans and implement those. So different than in my previous life within the publishing industry, able to take real-time student data in order to make those decisions. And with that, our goal is to actually get rid of versions altogether. What we want to create and what we're on our way to creating is an evergreen process where we're always constantly improving both our content and that adaptive engine behind it in order to improve student success. We're getting to that point, and probably within the next year or two, we won't have revisions anymore, which is a really exciting thing for us, and probably for you guys too, as you think about creating courses semester after semester. Making that a seamless update process, I think, is a pretty exciting thing. The other part of that, though, is in addition to collecting data on the back end, the students and you as instructors also have access to our feedback button on each and every question. Those come to our content team, and we're able to respond to those very quickly and make those improvements in real time as well. So with that partnership with the data science team, I want to give you a little bit of a snapshot as to the kind of things that we study with them, or that they study, and what that means for the student. So what we've seen across the board, across the students that we've studied, is that 87% of the time, students meet a mastery threshold in Knewton. That means that they are getting through the Knewton assignment successfully. They're reaching their instructor's benchmark. And that's great, but as a scientist, I would say, what does that mean? Does that mean that the content's just not hard enough, that they have all those video and text resources and answer explanations right there? You know, does that really prepare them for the test? So we went further in the analysis than just saying most students complete the assignments. What we saw is that students who we identified as struggling, so that means those students with poor academic backgrounds, relatively speaking, maybe students who took intro chem or who took high school chemistry a number of years ago, weaker math skills, things like that. That classification of students who are probably in the lowest 25% of the course of your roster, those students who typically stop doing an assignment partway through or get frustrated or drop the class pretty regularly, that subset of students was able to finish assignments 82% of the time. So we're starting to gather some evidence to indicate that the students who need the most help are actually achieving more because of this system. But again, there's more to the story than that. I need to know that they're not just finishing assignments. I need to know that they're successful down the road from that. So what we did next is look at what happens when a student took a quiz after the due date of their Knewton assessment. And what we saw across the board for all students, scores went from 55% of students who didn't finish the Knewton assignment, or those who were using a competitive system, to 81% for those who did. So right away we see some improvement in students who have spent time in the system and met that mastery threshold in Alta. But again, there's more to the story than that, right? As a scientist, I would say maybe that just means that they spent time in a system, and spending time in any system would help. So we broke this down to get a better idea of what that 81% actually looked like, what it actually meant, to see if it's just a ramification of doing some kind of studying or if it was a direct result of Alta. And the study that we did was actually to break the students down into where they came into the class. Those who were identified as struggling, those in the lowest 25% of the class on the first day, either of the class or of the assignment. Those that were in the highest 25%, those who probably really didn't need a lot of extra help and would have been fine on their own. And then the average student, those in the middle 50% of the class. And those are the three lines depicted, or the three line segments depicted on this graph. That light blue line at the top are the the advanced students, those who probably didn't need a lot of help, they came in pretty strong. They did well on the quiz. They would have anyway. The purple at the bottom are those struggling students, and the green in the middle is the average student. And what we can see here is that all three of those groups improved their quiz scores when they successfully completed Alta. Those who, the first data point on that graph, who had less than a 25% score, and then the second data point for each of those line segments, those who reached above a 75% mastery. So across the board, all three groups improved their quiz scores, but what's particularly interesting to me is the relative slopes of each of these lines. We see a much bigger improvement for those struggling students. They're staying in the system, they're finishing their homework, they're feeling empowered to do that. They're getting the support they need, even if it means that they're spending longer in the system than their more prepared counterparts are. That's what they need in order to be successful. But the slope of that line has increased. They're seeing bigger gains for that. And these are those at-risk students that we're always worried about losing in the class. So we're starting to really see some compelling evidence here that Alta is making a difference. We're keeping the students in the class in a very meaningful way. They're not just answering the same questions over and over again, but they're building a skill set, both on the topic in class, the prerequisites for that, and the math skills that they need to get there. So as a bunch of academics and data scientists, we kept going from here. It's great that these students did well on the quiz, but we want to see how they're doing in the long term. So we did actually a pretty interesting study, and if we can, here we go, to see how their learning rates changed throughout the semester. So again, we have our three categories: purple, struggling students; green is average students; and light blue here is the advanced students. And we looked at how much less time they spend on assignments as they go through the semester while still seeing those marked improvements in their score. And these students who are spending a particularly long time on those initial assignments, we see their time on task being reduced as they move forward. They're really getting not only the chemistry content and being able to retain that chemistry content that they need, but they're able to apply that to situations later in the class. They're not having, you know, their chapter 3 topics show up as chapter 7 prereqs or chapter 14 prereqs quite as often as we might have expected based on those initial data points, because of this retention that they've demonstrated. They're in that system long enough, built up the skills, have the confidence to move on, and they're able to apply those without much help or without nearly as much remediation as they move through the class. So we're really excited about digging into these kinds of studies, either as a whole across all of our users, or at a particular institution in a pilot, in a course, whatever the case may be. And as you think about adopting or implementing Alta in your class, very much we invite you to partner with us, partner with our content team or our data science team in order to dig in and make sure that Alta is producing the results that are important for your own department. I'm going to turn it back over to Donna so that she can tell us a little bit more about how she implements it, the things that were important in implementation in her class, and how she did those studies. But like I said, it's important to us to have those kind of partnerships with all of you for our own growth in the product, but it's also just a really fun thing for us to be able to study as well. So thank you, and I'll turn it back over to Donna.
Thanks, Andrea. Yes, as Andrea said, they do encourage partnership, and so I have been testing Alta in my classroom now for quite some time. Right now, how I use Alta in my classroom is that I go in and create my assignments based on the learning outcomes within the chapters that I want to cover. I can choose to turn on or turn off learning objectives through the create an assignment as I see fit. So that allows me that control over what I am teaching in my classroom. As I said before, the content in the chapter is on par with industry-leading texts, the difference being that it's chunked in much smaller learning objectives that are more palatable to students, so that they're not overwhelmed by reading a whole chapter and trying to remember what they're doing. They're getting specific instruction on a specific learning objective at that point, supported with these short videos. I like my students to go into the assignment and read that instructional material first and then attempt the mastery. But as Andrea said, that really is up to the student. They can go in and attempt the assignment, and it will still provide that instructional material as they need it. I like personally to go in when I make an assignment and preview as a student so that I can get a feel for the type of questions that the students are getting, and I can kind of sample the assessments. Obviously, the number of assessment questions is gigantic, and I can't see all the questions, but I can get a feel for those assignment, the wording and the tone of the questions, and kind of mimic that in my classroom a little bit. Alta seamlessly integrates with my LMS. We use Canvas here at Park. The students don't really feel that they are leaving Canvas. It opens up right inside that Canvas window. I utilize the feedback button anytime I find something that I think is a little questionable or it just needs a little clarification. A screenshot is automatically taken of the question or the page that I'm on, and it is sent directly to the support team, and they respond usually within 30 minutes, but definitely within 24 hours for any kind of improvements that need to be made. Next slide, please. So in general, my mastery assignments cover about 1 to 3 learning objectives. These are formative assessments. They are completion grades. So the students are encouraged, as I said, to read the related instruction prior to beginning the assignment. And then they work through the objectives and are served up instructional materials as they struggle. That could be for chemistry concepts or mathematical errors, whatever Alta diagnoses that they need at that. This saves me so much time in lecture so that I'm not spending an hour boring my advanced students trying to teach my struggling students how to rearrange to solve for a variable or different chemical concepts that we've already covered. I'm not going back over the material. The students are provided that in the assessment as they need it. And then the students are given their immediate feedback with explanations from the questions within that. So that's the formative side of my course. And then within the Alta system, I can set up some summative assessments in the form of quizzes and tests where I encourage the students to finish all the masteries first, then go in within the chapter and attempt the quiz or test. And that one, they don't get as much feedback. They only see their overall score and not the details until after the due date. So I have both the formative and the summative assignments within each chapter. Okay. As I said, the average student investment time on a mastery assignment of between 1 and 3 learning goals is somewhere between 15 and 40 minutes, depending on the level of the student's preparedness for that learning objective. I tend to assign about 5 to 6 mastery assignments per chapter. So the student spends approximately 2 to 4 weeks or 2 to 4 hours per week outside of class working on these mastery assignments. The quizzes are mainly short answer and multiple choice and about 10 questions, and usually take them approximately 25 minutes to complete. And those are once a week. So it's hitting that relative about 2 hours for every hour outside of class that they're working on this. So how I've incorporated it into my grading, the mastery and the quizzes together make up about 40% of the course grade, and the other 60% is split between the hour exams that are self-written, and the final exam, and of course the lab component of the course. And I just use a standard 10-point grading scale for that. So what I really like about Ulta is the fact that I can get immediate feedback for the students, and I can track what the students are learning, where they're unsure. I can get information like this directly off the data dashboard, or off the dashboard, that shows me how many students have completed the assignment, what's the average time they took on the assignment, how many are struggling, how many are still in progress, and then I can drill down within an assignment and look at one of those struggling students on the next slide. I can look specifically at a student to see exactly where within the assignment they are struggling. What are they getting? What are they not getting? And what other instruction have they been given? So that when the student comes to my office, I can not repeat what they've already heard. I can try to explain from a different angle. I also get an email notification from Alta that tells me that a student is struggling, and so I can reach out to that student as well and say, you might want to come visit me during my office hours. It looks like you're struggling on this concept. From time to time, I can also get some data from the data scientists at Alta to see overall from the course, from a starting point to a mid-semester, for example, how the students are tracking. So this is a diagram of one I got a few months ago, where you can see at the beginning point, I had this large number of struggling students, a very small advanced, and about 32% were average students. So it's that area in red that I'm really concerned about, and I don't want to lose those students. And if you look at the mid-semester improvement, the struggling students showed the most improvement, but per class. So even all students showed some improvement, but the struggling students really made great advances by mid-semester through using the product. Some of my own data, I've been collecting data for my classes for about 3 semesters now. Here are the fall of 2017 and spring 2018 data points. Again, I write my own exams, so I can go in and look at those students that have completed the mastery assignments at greater than 70%. So the students that reach 70% mastery or higher, and compare those to those students that did not reach 70% mastery. And I see on average about a 20% or 20-point grade improvement of the students that have actually completed to 70% mastery or more. That's especially true on those harder concepts when we're getting towards the 4th exam. And you can see that the harder the topics become, the greater that spread stretches out. So certainly tells me that the mastery assignments are making a difference. Just a little bit about the support I've received from working with the staff at Knewton. The technical support on getting up to speed on how to use the product, any problems I run into, and so forth through technical support is amazing. If I can reach out to anybody that I happen to have the phone number for, and if they can't answer it, they will immediately find someone who can. Email on demand. I've spoken with someone at 7 o'clock at night in Central Time, so I know that's 8 o'clock at night in New York. So it's very easy to get help. My LMS manager who installs all the tools says this was the easiest integration he's ever done. And as I said, it's seamless within Canvas. It automatically deposits the grades from the mastery assignments right into my grade book. I don't have to copy and paste anything. Any issues that I have, the feedback button response usually is within minutes, adjustments to content or questions within 24 hours. So just really great. I've presented some of the initial data of how effective this has been at regional American Chemical Society meetings, and the data scientists and content specialists have been really great to help me focus my data, use some of their data a little bit for a better presentation. And it's just exceptional to work with the Knewton staff all the way across. So with that, I think we wrap up, and I'll be happy to address any questions, or I'm sure Andrea or John will as well. So thanks for your time.
Thank you, Donna. If anyone has questions, please type them in the chat bar, the question bar, and we'll answer them for you. We'll leave a little while for questions. Okay, we're at time, so we're going to end the session now. However, we do have a question coming in. Is there a possibility that an Equilibrium Le Chatelier principle chapter will be added to GOB?
There is absolutely a possibility that will happen. That's something that we're actively working on right now, and it should be available in the summer.
Any other questions? Periodic trends questions?
Are you asking if we're adding more?
Yes.
I'm open to that possibility. We haven't started authoring any, but if you have specific trends that you think aren't covered sufficiently, pass that my way, and we'll make sure that we get there.
Oh, the question is, there's a section labeled periodic trends, but there aren't any questions inside.
Oh, that's interesting. Let me dig into that and get back to you on that. I haven't heard that before.
So what we'll do is, we have a record of any of the questions typed in, and so anything we don't answer during this session, we'll answer on email afterwards. You'll also receive a recording of this session, so you can watch it again and again. And in that email, you can just hit reply to, if you have another question that strikes you, we'll answer that. You can request a demo or get access to an instructor preview account. But anyway, thank you so much for joining us. And thank you, Donna. Thank you, Andrea, for talking to us about Alta and chemistry.
Thank you all for joining.